In this video, we're going to talk about why, in some cases, particularly for IK arms, it's a good idea to use a bone or joint as your controller. Now, I've got three examples here, and these first two are going to be kind of the setups I thought you could do previously. But we'll start with the end result here, so you get an idea where this is going. Um, and where this came up was I had a request for a rig that when you translate the arm controls, they move in tandem. So say your character's holding on to a handlebar or something like that, you stay together. But also I got to keep in mind the animation curves. And if you look at each one of these controllers, while they're in different positions in space, they have the same translate values, which means their graph curves are going to be the same. So there's a logic there. They know that if the graph curves for each of these hands looks the same in the graph curve editor, uh, they should be relative to each other in position, animating the same way. But on top of that, they wanted mirroring when it comes to rotation. And before this, I thought that was a one or the other option. You couldn't have both. And if you look at this rotation control, again, if you look at the values and I click on the other one, they don't change. They're the same. So there's, again, going to be that same kind of logic to the animation graph curve when they're animating. They can know that, hey, I'm getting a mirror position as long as my graph curves are the same, and that moving those graph curves will result in this type of motion. Um, so before, this used to be my setup, and let's open the outliner here, and we'll hit F to focus in on that control. So I have a control here. It's zeroed out. You see it's oriented. It's oriented the same way the joint is oriented. So if I click on the joint, you see our rotation gimbal does not change positions. Let's go ahead and show that one more time. I'm going to focus in on the joint too. So joint, control, joint, control. They're oriented the same way. And my control is zeroed out. And the reason it's zeroed out, but in position, is because we have the CT group. The CT group is a parent that was point and orient constrained to that wrist. And then we delete the constraints, but so it has the translate and rotation values. We never animate this, so we're not worried about those on there. But if we parent a control underneath, we now get the orientation while still being able to zero out our control. And my skeleton is mirrored, so when you mirror that, let's go ahead and select the CT group, and I'm going to switch over to object. So I'm going to pick walk up one, and you see Y is facing up here, or Y is over this way, Z's up, X is facing down the joint. But if we look at this one over here, because it's mirrored, X is facing up the joint. It's basically a 180 around. Now the reason for that is because that's what gives me my mirroring rotations. And let's go ahead and rotate these into position. And again, if we look here at our rotation values, you can see X, Y, Z is the same. Now the issue is when I start to translate. So right now, we're already starting to see this. I'm in object mode, so if I translate them, they're moving relative to the direction of the wrist. So you see they're not moving the same direction right now. But I'm trying to remember how this works. I believe they're getting the same values. Yeah, so you can see that they have the same translate value. So they're going to have the same graph curves, but they're going to be in completely different positions. Now, you might be saying, well, yeah, but we could just translate it in world positions. Let's go ahead and zero out those translations. I'm going to double click my move tool and switch to world for the move axis. I have both my controls selected, and I'm going to move them, and they're moving together. But now if we look at the translation values, they are not the same. So we're going to have different graph curves for that. So the alternative to that before was, well, I can give you the translation values you want. And again, if we look at these individually, same translation values. Let's do that one more time. But, grab both of those. But we don't, we don't have the mirroring animation on the wrist controls anymore, on the rotation. They're going the same direction as each other now. They're not mirroring. And that'll give them the same values, but again, different positions. So in this case, we have the translating working the way we want, but not the rotation. In this example, we have the rotation working the way we want, but not the translation. By the way, the way that we made these was on the CT group, it's not rotated to the joint. It's just rotated to world position, which is what allows us to get the translation we want, but again, not the rotation. So put those back. So how are we doing that with these? Because you're looking at, well, you got controls. Well, secret, they're joints. I've made joints that look like controls. And the benefit is I get a joint orient value and a rotation axis value. Now, if you watch my video on joint orientation, you probably know that joint orientation works essentially like the CT group on our controls that we've built over here, at least for rotation. That, if you look at this control, let's go back to the channel box, it's a little bit easier to see. It's in position, it's lined up with that wrist. Let's go ahead and open up our outliner again so we can do the switch back and forth and you guys can see this. Focus in on that, focus in on, focus in on control. So if we look at the wrist, look at my gimbal, the hand is in the same orientation, but we are zeroed out. But if you look at my translation, I'm still in a world, so that doesn't really count, but look what happens when I switch to local or object, it doesn't budge. It's oriented to the world. So my translation is oriented to the world, but my rotation is still oriented to the wrist. So I've got the best of both worlds in this. So let's talk about how I made this. And what we'll do is we'll go ahead and convert this guy over to that same thing. So I'm going to first duplicate the wrist joint. I'm just going to move it off to the side. This isn't a necessary step, but it makes it much easier to show you guys so you can see what's going on here. I'm going to unparent it. So let's look in the attribute editor, and if you look at this, it's already oriented. So it is aiming down this direction. Essentially what happened is, if you've watched our joint orientation video, it's been rotated in that position, and if you copy the rotation value and paste it in the joint orient value and zero this back out, it'll be, again, like how the CT group works. It's absorbing the rotation down here, so you can still have a zeroed out rotation, but your orientation is still here. Now that doesn't necessarily affect the translation part, and again, you can see our translate gimbal is also oriented that same direction. So we want to undo that, but keep our rotation. So we want our translation reset. Now, what we have up here is rotation axis. And with this, we can reset our rotation axis without changing our rotation and leaving our joint oriented the same way. Now, you might be thinking, well, how do we know what that value is? And in some cases, if you might be lucky enough to just stumble on this, and you might be going, well, in theory, if I undid this rotation, that would put it back to world rotation, right? And let's test that theory out. So opposite values of what's down here, and no, not really. You can see it's not, that doesn't look right. And certain rotations, you might be able to pull that off. I've done it by accident before. It took me actually a couple tries to figure it out, because the first time I did this, I happened to have a joint that all I needed, because of its position, I just needed to put in the opposite value and it worked. But in this case, that's not so much, that's not working. So we want it oriented to the world right now. How are we going to do that? Well, let's go ahead and create something that's oriented to the world. I'll go ahead and make a locator. And I'm going to bring it up here so it's a little bit closer. And it's oriented to the world. I've translated it, but I haven't rotated it. And let's go ahead and look in here so we can see the values. So you can see my axis is facing down, and it's zeroed out here. The only thing we have is translation values. So what I'm going to do is select my locator, select my joint here, and I'm just going to orient constrain this, my joint, so it's oriented the same way as the locator. And now we have some rotation values in there. And what that rotation value is going to be, looks like I did that. Oh, no, that's from duplicating it before. So I'm deleting my orient constraints. It had 2 in there because my original wrist had an orient constraint to follow the control, and I didn't think to delete it. But regardless, our joint is still oriented in the right position. And we now have rotation values on those. And so that's a rotation value that should be able to counter out our previous joint orientation to get us back to world space. So just like orienting a joint, I'm going to copy this rotation value and paste it into rotation axis. And you're going to see your joint spin all over the place as we do this. Don't worry about that just yet. Get all the numbers copied. So I have rotate x into rotate axis x, y to y, z to z. And once I have that, I'm going to zero out my rotation axis. And now you see this joint is oriented to the world. Again, we're in object space. And if we switch to local because it's parented to the world, same thing, world does not budge again. But if we go back to rotate, we are still oriented the same direction. And I couldn't do this with a control because I don't have these joint orient values on here. This is the key to making this work. This is why we're using a joint to do this. So all we need to do now is we need to put a spline control on here so it looks more like a regular control, so we're not reading a joint. And let's see, how do I want to do this? I'm going to undo this a little bit because we had already set this one up. So I'm going to delete the point constraint on the IK handle. I'm going to delete the orient constraint on the wrist. And I'm just pick walking down because I know they're children of those things. So if I pick walk down and use the side arrows, if I don't get the right one, like when I first pick walk down, I get this joint, but I also know there's an orient constraint as a child of this. So if I pick walk sideways, I would get it that way. So I deleted those. So if I move this wrist control, it's not driving those joints anymore. And again, you don't need to do this step. I'm doing this so you guys can see what's going on. You can leave this all right on top of each other and do this all from the outliner. So on this particular one, I've already got this hand control made, and you can see that it's only translated into space. It's not rotated into space. And that's what we want, because if we look at our joint, we need that too, because this joint is still going to have translation values on it, and we need to get those to be able to be zeroed out. So just so this isn't on top of the rest of the rig, I'm going to take this CT group and point snap it over to our joint. And let's parent our joint under that CT group. Now, if you're making this from scratch, all you'd have to do is make a group and point constraint, or not even point constraint it, just point snap it to the joint that you're working on. So that's, if that's where you want your control to be, just point snap it there. It'll have translation values, but no rotation values, just like this does. But with this joint parented underneath there now, you can see everything is zeroed out. Now, we also have this wrist control that was already made, and you're still going to want to make this. You're going to want to make it the same way we did before. Again, in theory, this is over the wrist already, so you're going to point an orient constraint to the wrist to get it in the right position. And then you're going to freeze transformations on it. So in this case, we're just going to parent it under the wrist to get it in the right orientation. So we want to double check that there's no rotations on it. I'm just going to freeze transformations for the hell of it, make sure that everything is zeroed out there by default. So just like when we make controls, sometimes you have multiple splines you want to turn into one control. And we're going to parent the shape node under this joint node. So in the channel box here with the spline control selected, I can see the shape name. I'm going to go ahead and select that and copy it. And down here in my script editor, I'm going to write the script for parenting a shape under a node. So parent, if I can spell parent, P-E-R-E-N-T, dash R for relative, dash S for shape. It doesn't matter which order you write those in, R, S, it could be one or the other first. And now I'm going to paste in my child first, the shape that I want to move, and copy my wrist joint name here and paste it in. So this shape node is going to be the child of this node here. And let's go ahead and select that and hit enter. And you can see my group, this group node here now, that's an empty node that doesn't have a shape under it. And it looks like my joint icon has turned to a spline icon. So as far as an animator is concerned, they don't think this is a joint anymore. They're just going to look at this and think that's a spline control because it looks like a spline control. Now, we still have that joint there, which might confuse them a little bit, but we could hide that. So again, if we go back into the attribute editor, under here, under joint, draw style, it currently says bone, we're going to change that to none. And now we have something that looks like a wrist control that has the properties of a joint, but is just going to animate the same way. Let's go ahead and rename this to how I had it before. And I'm just going to point constrain this back to the wrist now, because you guys can see it. And again, you didn't have to move it off to the side. I'm just doing that so you guys can see it a little bit better and not get confused of which joint's which. But now if we just select our control, select our IK handle, constrain point, select the control again, select the wrist, constrain orient, and I'll show you here. I don't have maintain offset on, and we go ahead and apply it, it doesn't budge. So the orientation is still the same, even though we have this translation value or orientation looking different. So now we've got the best of both worlds again. So because I have two hands over here, you know, I could translate this. I'm getting the same graph curves for this, same values on each side, and I get mirroring on rotation with the same values on each side. Now, just to point this out, this is great for IK limbs. So feet, this is a good option. Arms, this is a good option. You know, other things doesn't make a ton of sense. It doesn't make a ton of sense to do this for elbow pull vector controls. That, you know, they're just translating. They don't need to rotate. Doesn't make a ton of sense for the spine because it's just a vertical thing. You don't have another spine you need it to mirror with. Those single values are fine. It might make sense on face controls. So think about the logic of what you're trying to do. It's best for things that you need to mirror a certain way or move together. And face controls may not be that, because you might want those just purely mirror, because you know eyebrows don't need to move in tandem with something, unlike hands do. If I'm grabbing a staff, this works much better to keep the hands in the same spot on that staff. You know, eyelids, eyebrows don't need to do that. You might actually want them to mirror, in which case, again, this is not a good example of that. So limb seems to be the best place I've seen to use that. And so I've started doing this for all my IK hands now. So anyway, hopefully that's some new information for you guys, that's you've learned something new and you're not going, yeah, duh. I've been doing this for over 10 years now, and that's the first time I've seen that, and I am sure I could have done this the whole time, but I was never smart enough to figure that one out on my own. So anyway, that's why to use bones as controls, because it gives you that added benefit. So that's it, and keep making great stuff out there, guys.